Okay, let's talk a little bit about the octet rule, this rule of 8. Now, this octet rule is the driving force behind all chemical bonding. All elements would like to have a full octet. They will bond until they do so, this rule of 8. So in Lewis dot structure, we put dots around the symbol of a particular element, for example, oxygen, which has 6 valence electrons. We put 1, 2, 3, 4. We put them singly around it until we have to pair them. And there we go. We have 6 dots around there. Okay. What are some other ones? Carbon with 4 valence electrons. Okay, and it just follows. Group 1A has 1. Group 2A has 2. Group 3A has 3. Group 4A has 4. Group 5, 5. Group 6, yeah, you see the pattern developing here. 6, group 7, and group 8 has 8, with the exception of helium, which only has 2. And hydrogen and helium are the two exceptions here, because hydrogen and helium, they only have that 1s orbital that they can fill. So hydrogen and helium, their octet is 2. Okay, they're going to be happy either getting 2 or having 0. All right, looking at some of the others, hydrogen, 1 dot, has 1 valence electron. Any of the halogens, group 7, we'll use chlorine as example, has 7 dots, 3, 4, 5, 6, 7. Okay, and any of the noble gases, they're going to have 4 pairs altogether, and that's why the noble gases really don't want to bond, because they have the full octet already. So this driving force behind chemical bonding is all driven by an element's desire for the octet. And they'll either do this by gaining electrons. You'll see that the higher groups, group 7, 6, 5, typically 4, they will gain electrons to get up to 8. And the first 2, 3 groups, they will lose their electrons to get the 8 in ionic bonding. But we're going to be talking about covalent bonding here. We're going to be talking about sharing electrons. So none of the electrons will be transferred. However, they're going to be shared here. And sharing is covalent bonds. Covalent bonding. Now let's look at a very simple molecule, methane CH4. Now in order to work through these, we need to know the Lewis dot structures for each. Carbon, hydrogen, we have 4 hydrogens. Okay, and what I tell my students when I used to teach high school is connect the dots. Okay, connect the dots. And I'm not talking about any dots, connect unpaired dots. Connect unpaired dots. So these will pair up. These will pair up. These will pair up. And these will pair up. And rewriting that nice and neatly, we have single bonds between each carbon and each hydrogen. And each of these lines is a single bond representing a pair of electrons being shared. And we can check for the octet for all these species. Carbon, 2, 4, 6, 8. All 8 electrons there. Each hydrogen, remember, its octet's only 2. 2 there, 2 there, 2 there, and 2 there. Each hydrogen only having 2. So this is very good. Now, many molecules will be like this, able to easily put together. Let me clear the screen here. Let me do another one here. Let me bring the screen back up. Okay, how about water? H2O, oxygen, 6 dots, hydrogen, 1 dot each. Here we have an unpaired electron and an unpaired electron. Here we have an unpaired electron and an unpaired electron. And we have water. Now, unfortunately, some molecules aren't like this, like a jigsaw puzzle. Okay, some are more difficult. Let's use carbon monoxide as an example. Carbon with 4 dots, oxygen, as we just saw, with 6. Well, obviously something's up. We can pair these and pair these, but that's it. Okay, so we have a set of rules. First rule of these non-trivial, that's what I like to call them, these non-trivial Lewis dot structures, total number of electrons. Total the number of electrons. So here we have 4 electrons on carbon, 4 valence electrons on carbon. Let me put VE here, total valence electrons, and 6 on oxygen for a grand total of 10 electrons. Okay. Now, secondly, we have to determine what the central atom is. But here we only have 2 elements, so really there isn't going to be a central atom. But we need to start with what we would consider the central atom. And the central atom, in usual cases, will be either the element that's only there as one, CH4, our previous example, or 2 examples ago, there was 1 carbon, 4 hydrogens. It's pretty easy to determine that carbon is going to be the central atom. But the central atom has the greatest number of bonds it can make. So between carbon and oxygen, carbon can form 4 bonds, oxygen can only form 2 bonds, and that is going to be our defining characteristic. Most bonds, depending on its Lewis dot structure. Okay, so in this case, that's going to be carbon. We're going to consider carbon the central atom, even though splitting hairs, it's not. All right, after that, create a single bond between the central and all terminal atoms, all atoms on the outside. So single bond between central and terminal atoms. All right, so once we do that, let's see. I'm going to try to get a larger screen here. I don't know if I'm going to be able to or not. Well, we'll just fit it on here for right now. All right, single bond between the central and terminal atoms. So what we're going to do here is rewrite this. I'm going to use an eraser. Erase all this here. I'll redraw it, and that's where I'll be able to put all the additional rules. All right, that's good enough. All right, so we're going to do a single bond between carbon and oxygen. Rule 4 is, and that's going to take care of 2 electrons, so we're already at 10. Now we're at 8 electrons. Rule 4, put electrons as pairs on terminal atoms. And that is an N, not an M, terminal atoms. 2, 4, 6. Okay, so until we get the octet. Now we're down to 2 electrons. Rule 5, any remaining electrons go as pairs on central. All right, now rule 6, if no octet, double triple bonds. All right, so carbon doesn't have the octet, oxygen does. So I'm going to bring these pair in, and that's going to give carbon 2, 4, 6. They need some more. 2, 4, 6, 8. So there we go. I'm going to write it up here. It's going to be a triple bond between carbon and oxygen. One pair still on oxygen, one pair still on carbon, and we have our Lewis dot structure. All right, so total the number of valence electrons. Central atom is the one that can form the most bonds. Put a single bond between the central and terminal atoms. Then put any remaining electrons on pairs on the terminal atoms. If you still have any more, we had 2 more, put them on the remaining, or put the remaining electrons on the central atom. And then if you have not filled an octet, you need to bring in multiple bonds, either double or triple bonds in to get that octet. Let's verify. We have 2, 4, 6, 8, 8 electrons on carbon, 2, 4, 6, 8, 8 electrons on oxygen. And this is how you do the harder versions of these problems.